Okay, welcome back everyone. I'm Erik Malkavian, and this is Starship Simulator. I always want to say Starship Trooper. It's one of my all-time favorite films. But this is Starship Simulator. It's a pre-alpha dev build. This is tech demo number 3. So in my last episode, I did the training module for the bridge and scanning and navigation. You saw me travel with Ava, and I attempted to move the ship without her so that I could go ahead and short range scan the planet I really wanted to take a look at in the Alpha Centauri system, but I was not able to do that. So let's carry on. Engineering, cold start sequence. We're launching that training module. Let's go. Our vessel uses a warp drive.
Welcome to the Magellan-class Cold Start training module. My name is Ava. I'm the UN Space Fleet's AI voice assistant. In this module, we will review the correct procedure for starting up the ship's fusion reactor and then supplying power to the vessel. The ship is currently in a cold and dark state, so for your safety, I have taken the liberty of turning on your torch for you. To begin, follow the waypoints on your HUD to the lower floor of the reactor room.
Okay, when she says torch, that's the British name for flashlight. We call them flashlights. Ava, darling. Because if we had a torch, that would set this place on fire. Never mind. Let's not be mean. Alright, so we are currently, I'm not sure what deck we're on. Now, our fusion reactor is dead cold.
As you can see, the reactor is offline, and none of the ship's systems are powered. Our first task is to provide power to the engineering decks, so let's make our way to the start capacitor's room. Follow the waypoints on your HUD to the startup distributor.
Okay, so I assume we're going to turn on the batteries. Basically utilize the batteries for some sort of formed energy.
As its name suggests, the startup distributor routes energy from the start capacitors to the engineering decks, and also provides the reactor with the power it needs to create the initial fusion reaction.
Right.
You'll notice the device is already powered because the start capacitors are fully charged.
Of course.
Let's go ahead and get some lights on by connecting all of the breakers. Start with the G-deck breakers, as indicated.
Okay, so basically the capacitors store energy. They're recharged by the fusion reactor, just like in our cars. We charge, our battery starts our car, and then we charge our batteries using a generator. Okay, anyway. Basically. Alright, so we're going to... So what are we trying to do? We are junctioning from one deck to another. G-deck aft. Is G-deck engineering? Is that the deck we're currently
And now
on?
the F-deck breakers.
I'm not sure where this is coming from. This must be coming from the capacitors. These must lead to the capacitors. Okay, so live load voltage. So this is what's going in. 12.9 kilowatts. Okay. Alright, so yeah. Basically it's taking power from the capacitors. This is what it's currently showing. Each of these cables are routing power from the capacitor to this actual junction box breaker box.
And finally, the reactor supply itself.
Okay. Start capacitor. So we started the capacitors. Well, they're always charged. And it should always be connected. Anyway. Right.
Excellent. Now we can see what we're doing. You can go ahead and turn off your torch by pressing T. The reactor controls should now be online, so let's walk back to the reactor room and take a look. This console displays the reactor's vital information and provides you with full control over the reactor and its subsystems.
Wow, we got high temps.
On the left-hand side, we have the coolant section, which shows the liquid helium coolant flow and the condition of the magnetic field coils. On the right-hand side, we have the electrical section, which shows the reactor's main electrical bus, along with its input and output feeds. In the center, we have the reactor's main display, where we can control the fusion reaction itself. As you can see from all of these alarms, it would be impossible to initiate a stable fusion reaction under the current conditions, so let's fix that. The first thing we need to do is supply power to the reactor's internal bus, so go ahead and switch the reactor to startup mode by pressing the indicated button. Great! Now that the reactor has power, we can activate the vacuum pump to start purging the confinement chamber. The chamber pressure should now be dropping. To sustain a fusion reaction, we need an internal pressure of less than 10 nanopascals. While we wait for the confinement chamber to reach its target pressure, let's take care of the reactor's fuel and coolant supplies. Exit the reactor room via the door behind you, and follow the waypoints on your HUD to the cryogenic storage room.
Okay. So we're going to get those flowing, I assume.
These storage tanks hold all of the cryogenic fluids that are used to both fuel and cool the reactor. All 4 tanks are currently empty, so our first task is to begin the filling process. Let's start with the helium coolant. Head behind the storage tanks to access the helium cryo cooler.
Shouldn't they already have helium in them?
The cryo coolers use a process called magnetic refrigeration to convert gas into a cryogenic fluid, before pumping it into the connected storage tank. Start up the helium cryo cooler now by using the indicated control on its user interface.
Cryo cooler. Okay, so this is using...
Excellent. Now if you turn around, you'll find the helium refill valve located on the back wall. These valves control the flow of gases harvested by the ship's gas collection hardware,
Right.
which is located on the underside of the forward hull.
It's a scoop. Okay.
Go ahead and open the helium supply valve now to begin supplying the cryo cooler with helium gas.
Okay, got it.
If you turn around again and inspect the display screen connected to the helium tank, you should be able to confirm that the tank is now filling with fluid. We now need to perform the same sequence of events for the other 3 tanks. Helium-3 is the first of 2 fuels used in the fusion reaction.
Offline.
As before, power up the device using its user interface.
You kidding me? Okay, so we did that, and we started this one, then we hit this flow. Okay, so I'm just trying to understand this process here. Okay, so...
And now open the helium-3 refill valve behind you to start filling its associated tank.
Alright, so... Alright, so I see it goes to that one. Okay.
Next, we need to start filling the 2 deuterium tanks, so let's head over to the other side of the room.
Oh, these are deuterium tanks. Okay. Really? What? What are those? Okay, never mind.
Deuterium, also known as heavy hydrogen, is the second of the 2 fusion fuels. We store double the amount of deuterium compared to helium-3, because deuterium also fuels the reactor's neutral beam injectors. As before, turn on the first deuterium cryocooler.
Wow. This is a lot of information. Whoever's the engineer is going to have to learn a lot.
And now the first deuterium refill valve behind you.
Okay, let's see here. How do I know that's the first one? I don't see where that's leading. Okay, so they probably... That's not finished yet. Okay, that's why. It's not finished yet, because it's supposed to lead to this tank. Okay, alright. It's not finished like... See, I'll probably go crazy if I do this. It's not finished like these. You can see where those lead to. These are leading to, like, nowhere. Okay, so that's really why I got that.
Next, turn on the second deuterium cryocooler.
Okay, so did that. Deuterium cryo cooler. Okay.
And now the second deuterium refill valve.
Right.
Okay, perfect. All 4 storage tanks should now be filling with cryogenic fluids.
Are they?
For our next task, we now need to engage the cryopumps in order to start supplying the reactor with everything it needs. Make your way around to the other side of the tanks and locate the deuterium tank outflow valve.
Whoops. I'm trying to see if I can see these tanks filling up. Probably have to look over this video again. Temperature, flow rate. It says it has a flow rate. I don't see how you see how much is actually in there. Flow rate. Alright, so. Alright.
Open the deuterium outflow valve to begin supplying fluid to its connected cryopump.
Okay.
Next, power on the pump itself using the button indicated on its user interface.
Okay, so that was the valve that's supposed to be going to somewhere else. Oh, it's coming out here. This is supposed to be connected to something else. Okay, so...
Excellent. That's half of the fuel mix taken care of. Now head over to the helium-3 tank outflow valve so we can complete the fuel supply.
Right.
As before, begin by opening the helium-3 outflow valve.
Right. Valve outflow. Oh, shit. I think I pressed the wrong one. Crap. There are 2 of them, so...
And now engage the helium-3 cryopump.
Alright. That was kind of dumb.
Perfect. All we have to do now is take care of the coolant flow. Now open the helium outflow valve.
Oh, crap. Yeah.
And finally, power on the helium cryopump.
Man. Yeah, I got this out of order.
There we go.
That
The
was very
reactor is
bad.
now being supplied with all the fuel and coolant it needs. Follow the waypoints back to the reactor room, where we have just a few more valves to open.
Okay. Yeah, I better slow down. Thank you, Ava. So I assume, where are we? We're on G deck. Okay. Got it. I'm so used to looking at Star Trek. Make sure we have flooring on.
To complete the coolant loop, open the helium inflow valve to start flowing coolant through the magnetic field coils.
Okay. That's the return, and this is the supply valve.
Now make your way around to the opposite side of the reactor to complete the... First, open the deuterium inflow valve.
Okay, supply valve, right?
And now open the helium-3 inflow valve.
Right, another supply valve. Right, okay.
Okay, great. Let's head over to the reactor controls and take a look at the coolant display.
Okay.
As you can see, we now have coolant flowing into the reactor. This has begun the process of cooling down the magnetic field coils,
Right.
which must reach temperatures below 20 Kelvin in order to become superconductive.
Okay. And
Okay, the temperatures look good. You can now power up the field coils.
press the highlighted button. Yeah. Okay.
With a solid vacuum established, the field coils powered up, and fuel flowing into the reactor, you are now free to initiate the fusion reaction.
Okay. Initiate. Here it goes. Nothing.
Congratulations! You have now successfully started the fusion reactor. For safety, the reactor automatically starts up at only 10% of its rated power. This means high voltage systems, such as the FTL drive, will be underpowered until you increase the reactor output. Let's resolve that now. Increase the power level to 100% using the indicated controls.
Whoa. Wow. This is on.
You'll notice that you can increase the power beyond 100%, but doing so for an extended period will overheat the reactor, causing damage and forcing an uncontrolled shutdown. Okay, we now need to provide power to the rest of the ship. With the reactor now powering itself, you can go ahead and switch the internal bus mode from startup to supply.
Was that supposed to turn us up to 100%? Backspace. Hold on.
Okay, you'll notice that you can increase. Let's resolve that now. Increase the power level to 100% using the indicated control. You'll notice that you can increase the power beyond 100%, but doing so for an extended period will overheat the reactor, causing damage and forcing an uncontrolled shutdown.
Let's not do that.
Okay, we now need to provide power to the rest of the ship. With the reactor now powering itself, you can go ahead and switch the internal bus mode from startup to supply.
Okay. Right. Understood.
Perfect. If we now head around to the opposite side of the reactor output distributor should now be powered up. This device distributes the reactor's output to the ship's high voltage systems, which are in fact the only systems powered directly by the reactor. The rest of the ship is powered by 48 individual battery arrays,
Okay.
which we now need to begin charging using the reactor's output.
Right.
Go ahead and connect all 5 of the output breakers here.
Okay. Connect.
Excellent. If you turn to your left, you'll see the 5 high voltage distributors are now coming online. Head over to the main battery distributor. This device takes the high voltage reactor feed and distributes it to each of the 8 battery rooms on F deck. Go ahead and connect all 8 output breakers.
So there are 8. What did you say?
This device takes the high voltage reactor feed and distributes it to each of the 8 battery rooms on F deck.
Okay.
Go ahead and connect all 8 output breakers.
So there are 8 battery rooms on F deck with 6 batteries in each of them. Okay. Okay, what happens if F deck gets taken out? Alright, what's the redundancy? Ava? Anyone?
Perfect. The battery arrays should now be charging, but we should perform a visual inspection to make sure. Follow the waypoints on your HUD to port battery room 1.
Port side. Okay, so currently we're on the port side of the ship, which is left. Those who are not familiar with ships. Alright, we're going to take a
The electrical supply on Magellan-class starships is divided into 4 isolated quadrants: forward, aft, port, and starboard. For increased redundancy, each quadrant is powered by 2 physically isolated battery rooms just like this one. Should the battery arrays in one room cease to function for any reason, the arrays in the second room will continue providing power to that particular quadrant.
Similarly,
power to one quadrant can be lost entirely, without impacting the supply to the remaining 3 quadrants. Okay, let's take a look at one of the individual battery arrays.
Okay.
On the left-hand side of the user interface, you have controls for managing the input and output breakers. And in the center, you have controls and information relating to this array's 10 solid-state battery cells. If we did everything correctly, all of the cells should now be slowly charging up. For the next step, we now need to connect each of the 8 battery rooms to the ship's electrical grid. This task will take us into the ship's labyrinth of maintenance tunnels, so be sure to watch your head. Follow the waypoints on your HUD to port battery aggregator 1.
Okay. Notice the hatchway. Very nice, very nice.
Each battery room has a corresponding battery aggregator, just like this one.
Oh.
These devices perform load balancing and also combine each room's 6 individual battery arrays into a single high-voltage feed. Go ahead and connect the output breaker now, which will connect this set of battery arrays to the ship's electrical grid.
1, 2, 3, 4, 5, 6. Alright, so that will connect.
Okay, 1 down and 7 more to go. Next, head over to port battery aggregator 2. As before, connect this aggregator's output breaker.
Okay.
That takes care of the port battery rooms. Let's make our way to the forward quadrant next.
She's like, push the button. Now. Do it now. Okay, so we're going forward.
Go ahead and connect the output breaker.
Okay, I'm just looking over the...
And the same again on forward battery aggregator 2.
Okay. Just want to make sure those are powered.
Okay, onwards to the starboard quadrant.
Okay, that's on the other side of the ship. That's forward. Oops. Yeah, it's unfortunate this is all on one deck.
Same again. Connect the output breaker. And the second starboard aggregator.
Okay. Those are all powered.
Almost
That's
done. Just the aft quadrant to go.
Of course, 4.
Connect up the first aft aggregator. And finally, the second aft aggregator.
These these quadrants are kind of close.
Okay, perfect. All 48 of the ship's battery arrays are now connected to the electrical grid. All we have to do now is supply power to the ship's remaining decks, and then perform a few cleanup tasks. We can do most of that from the reactor room, so let's head there now.
Of course we can.
Follow the waypoints on your HUD to the forward deck distributor.
Forward deck distributor. Okay. Whoa. Those are the type of steps that you hold the handrail and slide down.
Each deck in a given quadrant is fed by a deck distributor, which takes the total electrical load of that quadrant, and then load balances it between the 2 connected battery aggregators. Go ahead and connect the output breakers for all 7 decks in this quadrant.
Okay, so there's the internal bus. Go ahead and connect the output breakers for all 7 decks. Okay. Right
Okay, now head over to the starboard deck distributor and do the same.
So that was the forward quadrant, okay. starboard quadrant. Alright. There's a lot of connections for this. But I guess that adds...
And now the aft deck distributor.
Adds some redundancy.
And finally, the port deck distributor.
Gotta read what we're doing. Okay, port quadrant, deck distributor. You see the lights there. C deck, D deck, E deck, F deck, G deck.
Perfect. All quadrants on every deck now have power available from the ship's main battery arrays. You'll notice, however, that the ship is still under emergency lighting conditions, because F and G decks are still using the start capacitor's supply. To resolve this, we simply have to switch the 4-quadrant distributors on F and G decks over to the main battery feed. Head over to the G deck forward quadrant distributor. Each deck has 4 of these devices, 1 for each quadrant. They are fed by the corresponding deck distributor. Go ahead and switch this quadrant over to the main battery feed.
Okay.
That's better. Now we can really see what we're doing. Now head over to the starboard quadrant distributor and do the same.
Wow.
And now the aft quadrant distributor.
Definitely going to need a manual in order to do this correctly.
And finally, the port quadrant distributor.
G deck port.
That's G deck taken care of. Let's do the same for F deck.
Right.
Head upstairs to the F deck forward quadrant distributor. As before, switch this device over to the main battery feed.
There we go.
And now the same on the starboard quadrant distributor.
Starboard.
And again on the aft quadrant distributor. And finally, the port quadrant distributor. Well done. That's the main objectives of the cold start procedure complete. But we have one final bonus task to perform.
Okay.
Follow the waypoints on your HUD up to the bridge, and we'll make the ship flight ready.
Absolutely. I knew you were going to say that. I was hoping you were going to say let's go to the bridge. Deck 1. There's deck E. Deck D, habitation upper. Deck C, science lab. Deck B, bridge. It's got an elevator. Nice. Command deck. Restricted asks. Right. Very restricted. Marines to be posted there.
The lights and bridge systems are still turned off, so let's bring everything online. Head over to the A-deck distributor in the engineering alcove.
Okay. Wow. Yeah, we
Now
need...
go ahead and turn on the bridge lighting.
Okay. Bridge lighting.
And now power up the bridge systems.
Okay, bridge hardware.
Okay, there we go.
What?
You have successfully started the fusion reactor, routed power to all of the ship's decks, and brought the bridge online into a flight-ready state. This concludes the Magellan-class cold start training module. Good luck, and I hope you'll join me again in future training modules.
Okay, that was wonderful. I feel like an engineer. I feel like a nuke on a submarine. That's what we call them. The engineers that do the work back in engineering on subs. A nuke. Alright, well, thank you for watching this. I'm Erik Malkavian, and that has been the engineering cold startup training module for Starship Simulator. This is tech demo number 3. That was very fun and very educational. Really like the realism there, and I like the systems. So, thank you very much for watching, and we'll be back shortly for the main mission. Take care. I'm Erik Malkavian. Goodbye. Goodbye. Okay. Goodbye. Goodbye.